Welcome to Simultaneous Equations Level 5. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving y equals 2x minus 1 and y equals x squared minus 2x plus 2. Now, since the first equation is linear and the second one is non-linear, we want to solve these by substitution. And this means that we want to look at the linear equation, because that's the simplest one, and take 2x minus 1. And since we know this is equal to y, we can substitute this for y in the second equation. And so the second equation, y equals x squared minus 2x plus 2, becomes 2x minus 1, because we've substituted y for 2x minus 1 from the first equation, is equal to x squared minus 2x plus 2. What we now have is a quadratic in terms of x, and to solve a quadratic we need to make it equal to 0. So to do that, I'm going to subtract 2x from the left side and do the same on the right, and I'm also going to add 1 to the left to get rid of the minus 1 and do the same on the right. On the left, the 2x and the minus x, the minus 1 and the plus 1 all cancel out to leave us with 0. And on the right, we have x squared, minus 2x is minus 4x, and 2 plus 1 gives us positive 3. There are several ways in which we could solve this equation, but because we just have a single x squared and the numbers are quite small, I'm going to try and factorise. So to factorise an expression like this, I need to find two numbers that multiply to make 3 and add to make minus 4. And those two numbers are minus 3 and minus 1. Because minus 3 times minus 1 is 3, and minus 3 minus 1 is minus 4. So I can take those two numbers and put them into two brackets, each with an x at the start. So we have x minus 3 multiplied by x minus 1. And now I've factorised, I can solve. And I can solve this by saying if two brackets multiply to make 0, then we need one of those brackets to be 0. So either x minus 3 needs to be 0, or x minus 1 could be 0. And if x minus 3 is 0, we can remove the minus 3 by adding 3 to both sides. And on the left, the minus 3 and the plus 3 cancel out to leave us with x. And on the right, 0 plus 3 is 3. So x is equal to 3. Next, if x minus 1 is 0, again we can remove the minus 1 by adding 1 to both sides of the equation. And on the left, we're just left with x. And on the right, 0 plus 1 is 1. So x equals 1. And those are our two possible values of x. We now need to find matching values of y, and to do this we're going to use the first equation since y is a subject and it's also the simplest one to use, so that's y equals 2x minus 1. So starting with when x equals 3, we can substitute this in and this equation becomes y equals 2 times 3 minus 1, and since 2 times 3 minus 1 gives us 5, y equals 5 matches x equals 3. We can now do the same for when x is 1. So when x is 1, y is equal to 2 times 1 minus 1, and 2 times 1 minus 1 is 1. So y equals 1 matches x equals 1. And so what this means is our final solution for problem 1 is x equals 3, y equals 5, and x equals 1, y equals 1. And it's important to pair these correctly. In problem 2, we're solving xy equals 6 and y equals 7 minus 2x. Again here we have a non-linear equation, which is the first one, and a linear equation, which is the second one, which means that we need to solve this by substitution. And since we have y as a subject in the second equation, we can take 7 minus 2x and substitute this for y in the first equation. So the first equation, xy is equal to 6, becomes x multiplied by, and we can now substitute 7 minus 2x in place of y, and that's equal to 6. We now have an equation that just has x's in, so we can solve this, and we can start by expanding the bracket. So x times 7 gives us 7x, and x multiplied by minus 2x gives us minus 2x squared, and that's equal to 6. And since this is a quadratic, we want to make it equal to 0. And what we really want here is for the x squared term to be positive. It tends to make things a bit easier. So we're going to make the left-hand side 0, and we can do this by subtracting 7x from the left and making sure we do the same on the right, and then adding 2x squared to the left, and again making sure that we do exactly the same on the right. So the 7x and the minus 7x cancel out on the left, and so do the minus 2x squared and the plus 2x squared. So we get what we wanted, which is 0 on the left. And on the right, we've got a 2x squared, a minus 7x, and a plus 6. Now again, there are a number of different ways you could solve a quadratic like this. You could try factorising this, but because a number in front of the x squared is not 1, the quadratic formula tends to be a nice way of doing this. So in order to use a quadratic formula, we need to write down the values of a, b and c. So a is the number in front of the x squared, which is 2. b is the number in front of the x, which is minus 7. And c is the number that's at the end, the constant, which is 6. So if we plug these into the quadratic formula, we get x is equal to minus b. Now, since b is minus 7, we get minus 7, which just becomes 7 plus minus the square root of b squared. And again here, because b is negative, we have to make sure that this goes in brackets. It's all of the minus 7 squared, minus 4 multiplied by a, which is 2, multiplied by c, which is 6. And that's all divided by 2a, which is 2 times 2. If I put this into my calculator, I'll get two values, once for the plus and once when I use the minus. So with the plus, I get x is equal to 2. And if I substitute this in with a minus, I get x is equal to 1.5. So these are my first two parts of the solution. To find the matching values of y, we now need to substitute these into the linear equation. And we're going to use this one because y is already the subject. And we can find the values of y that correspond to each of those values of x. So starting with x equals 2, we have y is equal to 7 minus 2 times 2. And 7 minus 2 times 2 is 7 minus 4, which is 3. So y is equal to 3, matches x equals 2. If we now make x equal to 1.5, we have y is equal to 7 minus 2 times 1.5. And 2 times 1.5 is 3, 7 minus 3 gives us 4. So y equals 4 matches x equals 1.5. And we need to pair these correctly. So our final solution to problem 2 is x equals 2, y equals 3, and x equals 1.5, y equals 4. In problem 3, we're solving y squared plus xy equals 3 and x equals 3y minus 2. Now again, the first equation here is non-linear and the second one is linear. So we need to solve these by substitution. And we're going to take the simplest equation, the second one, and since x is the subject, we can substitute x in the first equation with 3y minus 2 from the second equation. So the first equation, y squared plus xy is equal to 3, now becomes y squared plus, and we're going to substitute the x for 3y minus 2. We still have a times y after it, and it's still equal to 3. We now have an equation that just has y's in. So we can solve this and we can start by expanding the brackets. So this becomes y squared. We then have y multiplied by 3y, which gives us plus 3y squared, and minus 2 multiplied by y, which is minus 2y, and that's equal to 3. We can now tidy up the left-hand side by collecting together the like terms, and y squared plus 3y squared gives us 4y squared. So we have 4y squared minus 2y is equal to 3. Now again, this is a quadratic, so we want it to be equal to 0. So I'm going to subtract 3 from the right to make that side equal to 0. I need to make sure that I do the same on the left. And so the left becomes 4y squared minus 2y minus 3. Now to solve this quadratic, and again, because we have a number in front of the y squared that's not 1, it tends to be easiest to use the quadratic formula. So here, our value of a is 4, b is minus 2, and c is minus 3. If we now substitute these values into the quadratic formula, we have, in place of x, y, since our equation is in terms of y, is equal to, we have minus b. And since b is minus 2, we have minus minus 2, which is just 2, plus or minus the square root of b squared. And again, b is negative, so we have to make sure that we put that in brackets. So minus 2 in brackets squared, minus 4 times a, which is 4, times c, which is minus 3. And that's all divided by 2a, so 2 times 4. And we can now just put this directly into our calculator. And if we do this with a plus to start with, we get to 3 significant figures. Y is equal to 1.15. And if we do this again using the minus on our numerator, we have y is equal to minus 0.651. If we now take each of these y values and substitute them back into the linear equation, because the linear equation is already written in terms of x, and it tends to be easier to use in general, we have when y is equal to 1.15, x is equal to 3 times 1.15 minus 2. And if we work this out, we get x is equal to 1.45 to 3 significant figures, and these two are a pair. If we now substitute y is equal to minus 0.651 into our linear equation, we get x is equal to 3 times minus 0.651 minus 2. And this gives us the three significant figures x is equal to minus 3.95. And so these two are also a pair. So our final solution to problem 3 is x is equal to 1.45, y is equal to 1.15, and x is equal to minus 3.95, y is equal to minus 0.651.